अस्सलाम वालेकुम डियर स्टूडेंट्स। तो आज जो हमारा टॉपिक है दैट इज मेथड ऑफ इमेजेस। तो वी हैव ऑलरेडी डिस्कस्ड दिस topic in our classrooms. So, and this is one of the application or this is one of the problem we can solve it with the help of these method of images, right? So as it is clear, so you can see that we have a charge. Our charge here, it is placed above an infinite plane as shown in the figure, right? So we have infinite plane here, right? And it is grounded. So that means the potential at the surface of this infinite plane will be zero, right? So V will be zero here. Okay. Now this charge is placed at a height edge, right? So we need to calculate because this charge which is placed at a height edge, जो यहाँ पे charge है, it will induce some charge on this, right? Negative charge and positive charge will be on the lower side of this infinite plane, and that will go to ground. So this indicates that positive charges will go to ground. So that means we have only that negative charge on the near the surface of this infinite plane, right? तो what basically method of images आपको ऑलरेडी पता है, हमने डिस्कस भी किया था क्लासरूम में। तो हम कैसे कैलकुलेट करेंगे लाइक इलेक्ट्रिक फील्ड और पोटेंशियल इन सम पॉइंट which is lying above this infinite plane, right? तो यूजिंग द मेथड ऑफ इमेजेस, सो फर्स्ट पहले हम ये क्वेश्चन पढ़ेंगे प्रॉब्लम क्या है। तो हमारे पास एक चार्ज है, so we have this the negative palette, this positive palette of this infinite plane goes to ground, so we have only this positive charge। तो अब हमें क्या करना है, we need to calculate that the this surface charge density at point C। तो C पॉइंट पे हमें surface charge density करनी है, निकालनी है, and this is having this contains the charge of minus q by 2, right? So we want to calculate the surface charge density at point C now, right? तो हमें पता है, we have discussed this in classroom, तो हम कैसे इसको हैंडल करेंगे। So instead of that, अगर हम ये palette remove करेंगे, if we remove this palette, right, and we put some image charge here, so you can see here। तो यहाँ पे charge ये है already, this is our real charge and this is fictitious charge जो हम यहाँ पे use करेंगे, that is minus q, okay? So which is lying at a height h, we can see that। So it's also lying at a height h, okay? And जो यहाँ पे charge distribution है over this plane, so it forms a circular uh, it forms a circular area here with radius x, right? Now अब हमें क्या करना, कैलकुलेट करना है, हमें कैलकुलेट करना है व्हाट विल बी द सरफेस चार्ज डिस्ट्रीब्यूशन एट पॉइंट सी। तो ये वाली प्रॉब्लम दिस इज इक्वल टू दिस। तो यहाँ पे सिंपली हमने प्लेट लिया, तो इसको हमने ग्राउंड मतलब पॉजिटिव चार्ज दिया, तो वी हैव सम पोटेंशियल हियर एंड वी कैन कैलकुलेट द सरफेस चार्ज डिस्ट्रीब्यूशन, right? Now, instead of that, we can use that method of images. We put some fictitious charge here, and we can calculate the surface charge distribution at point C. कितना charge distribute है, and we can first calculate this electric field due to this A on this C, and then due to this image charge as fictitious charge at point C, right? So let's first write now the field due to this. So field due to this, we can say that. So we can write this field due to A at C, right? So it will be, or you can write that because field at this point C will be due to this point, this charge Q and minus, right? So we can write now first the field due to this charge which is placed at point A, right? Uh, Q of A at C, right? So this will be equal to, so you can write this as this will be equal to Q by 4 pi epsilon naught, okay? And this much of distance, because you are calculating the field due to this charge which is placed at A on this at point C. So this will be that 1 by 4 pi epsilon naught q by r square, right? So into 1 divided by, that will be this AC square, right? Or you can write in vector notation, you can write this as Q upon 4 pi epsilon naught AC upon AC. Right? So this is AC vector. Because you can write in vector notation. So the field due to A at point C. Okay? So this first. And similarly, we can calculate the field at point C due to point B. Right? Or you can write down what is the field due to point due to charge which is placed at a distance of h below that plane, which is located at point B. Okay, so we can write this as, so this will be equal to Q upon 4 pi epsilon naught, and this will be BC vector upon BC. Right? So you can okay. Now, what will be the direction of the field at this point? What is the direction of field? So because this is positive charge, so it will repel, so it will be like this one, and this will attract, so it will be like this. So using that triangle of vectors, so we can resolve it. So this will be the direction of the at points. तो जो डायरेक्शन फील्ड की होगी इस पॉइंट पे सी पॉइंट पे सो इट विल बी डाउनवर्ड्स राइट ओके नाउ इफ यू कैलकुलेट नाउ what will be the total field, right? Or you can write that total field at point C will be the sum of Fa plus Fa. So that means the total field will be, or you can write that this is field, you can write this as E of A, E of A. So field, electric field, right? So we can have this E will be equal to, that will be equal to EA, or field at point C will be equal to EA plus E. Okay. So what will be total E here? So total E will be at C will be equal to, that will be equal to EA plus E. Okay. Or you can write this as Q upon 4 pi epsilon naught, right? And for this, what's AC here? You can add that AC that will be AC plus BC divided by, or you can write instead of that, you can add BC cube. So I'm summing up because the field होगा due to point A, it will be that Q by 4 pi epsilon AC divided by that AC cube. But we have this AC will be equal to BC because these are at equidistant. Okay, so you can write instead of this, but this is vector notation. You cannot write AC equal to BC. This is the direction of the vector. Okay, but in the denominator, this is simply the magnitude, and they have same magnitude. You can write that AC will be equal to BC. So this will be this one. Or you can rewrite this equation as it will be Q upon 4 pi epsilon naught. And what will be AC plus BC here? That's AC plus BC. That will be equal to AB. Because you can use that. This will be that AC plus BC. That will be equal to AB. So this will be AB vector upon BC. Okay. So this is the electric field at point. Or you can rewrite this as Q upon 4 pi epsilon naught. And what's AB? That will be 2H upon, and this BC, or you can add this BC will be equal to using that, so this will be H square plus X square. So it will be H square plus X square raised power 3 by 2. Why? Because this is simply the magnitude. So mod of that. You are taking the mod of this BC. So mod of BC will be that square root of that x square plus h square, because you are taking this distance, right? So this will be h square plus x square root of this, and it is already cubed here, so it will be h square plus x square raised power 3 by 2, right? So it's okay. So this is our EC. Okay. And what will be the direction of this field at this point C? So the direction of the field will be downwards, because as I already told you, because this charge will repel here, right? Okay. So it will be downwards. So this will attract, right? So the field will be in the downward direction. So this arrow indicates that this is the direction of the electric field. Okay. Now what is surface charge density now? So if you write to the surface charge density, you might know that this sigma, that's our surface charge density, that's equal to epsilon naught into E, right? So this E is known to us, right? Or you can rewrite this as, this will be Q upon 4 pi into 2h upon I square plus x square raised power. Okay? Because you have epsilon naught in the denominator here, तो ये epsilon naught ये cancel हो जाएगा. So यहाँ पे मिलेगा हमें q by 4 pi and this term, and the field, the surface charge density will be. Okay. Now you want to calculate the total surface charge density here. So let me rub this part here. तो यहाँ पे मुझे क्या करना है? I need to calculate total surface charge density here. So you have this infinite plane, right? And we have a charge here, Q, which is located at a height h above from this plane, and it is perpendicular right angles to this infinite plane, and we have this circular charge distribution here, right? Now what will be the total circular area of this charge distribution? So if you write now, what will be the total circular area? Or you can add that total circular charge, total circular area, or you can add this total charge, you can see that, because it is total charge on the तो total charge कितना होगा इस circular ring पे, right? Or circular ring you can write, because so we can divide this in n number of elements. So we can write this as, that's equal to 2 pi x into d of x. So this is that 2 pi r, right? Because it is that the radius of this ring is, it is r, sorry, it is x. So that's why I write 2 pi r. So instead of this radius of x, and you calculate for some differential element, small element. So for small element, it will be d of x. Okay. Into that total electric field, because this is our sigma, that's epsilon naught into E, and you need to multiply it by you can multiply it by twice QH upon 4 pi into x square plus h square raised power 3 है. तो यहाँ पे मैंने क्या किया, तो क्योंकि मुझे टोटल जो चार्ज सर्कुलर रिंग पे निकालना था, तो अगर हम इसका स्मॉल एलिमेंट लेंगे d of x, and you calculate the total this circumference, total area, that's 2 pi r है, तो इस रिंग पे कितना चार्ज होगा, so that will be 2 pi r into d of x per small element into that total field, right? So you can write this as, so this will be equal to, so if you calculate this this total charge density here. So that will be from 0 to 4. You can write that this is the radius. Uh, that is because 2 pi and 1 will cancel. So you will write here. So let me write this will be Q H x upon x square plus h square. So you can now it's very easy to calculate because you can write that what your sigma here, right? So that will be equal to. So I cannot calculate it. So it is simply you need to put that x square plus h square some t square. Then you can write that 2x d of x will be equal to 2t dt. And you also change the limits. So limits will go from h to square root of r square plus h square. Okay. Right. And inside will be that will be q h into t by t cube dt. Right. Now if you integrate this, so you can write that what will be our total surface charge density. Right. So this comes out to be, so you can calculate it. So that will be equal to minus qh into square root of r square plus h square minus h. Okay, so this is what we have calculated because you can do that substitution. So ये बहुत easy है, so you can do it because time is limited. I cannot show you everything here. So you can calculate here by making substitution, and also limits will change because I am putting here 0 to r. Huh? Right. So because okay, so this is the total this surface charge density, right? And what is the मतलब fun of doing this method of charges? तो ये मैंने आपको आगे बताया कि हम method of charges क्यों कर रहे हैं. तो अगर फॉर एग्जांपल अगर हमारे पास यहाँ पे metal conductor होगा, so we are grounding it. So positive charge of this metal, this infinite plane will go to ground, so that means we can have potential at the surface of this infinite plane will be zero, right? So अगर हम यहाँ पे we have a charge here, right? Now if you want to calculate field at any point, suppose we have some point P here, तो अगर हम field या potential इस point पे निकालना चाहते हैं, आप can write like जैसे हमने यहाँ पे surface charge density निकाली, we can also calculate electric field at some point above that plane, right? तो इसको रिप्लेस करने के लिए हम वी कैन विद द हेल्प ऑफ दिस मेथड ऑफ चार्जेस, तो हम एक इमेजिनरी चार्ज यहाँ पे कैलकुलेट मतलब रखेंगे एट सम डिस्टेंस इक्वल टू दिस वन, राइट? और जिसको मिरर चार्ज भी कहते हैं. तो देन वी कैलकुलेट द फील्ड प्रोड्यूस्ड बाय क्यू ऑन दिस पॉइंट एंड फील्ड प्रोड्यूस्ड बाय दिस मिरर चार्ज ऑन दिस, राइट? तो जो यहाँ पे वैल्यू आएगा due to this main charge and the real charge, due to this real charge and fictitious charge, जो यहाँ पे वैल्यू आएगा इलेक्ट्रिक फील्ड और पोटेंशियल का at this point, so that will be equivalent to जो यहाँ पे induced charge हुआ due to this charge, due to this charge we have some induced charge, negative charge on the surface, so the field due to this charge and the induced charge, तो यहाँ पे जो वैल्यू होगा it will be equal to the earlier one. So this is the beauty of this method of charge, and maybe in coming lectures I will show you some more problems on this method of image. Thank you.